Welcome. Today we're diving into the world of precision measurement with the Vernier Caliper. This tool is a staple in laboratories, workshops, and classrooms, known for its ability to measure with remarkable accuracy. Whether you're a student, engineer, or hobbyist, understanding how to use a Vernier Caliper can open up new possibilities in your projects. Let's start by exploring what makes this instrument so special and why it's trusted by professionals around the globe. Get ready to unlock the secrets of accurate measurement as we journey through the basics and beyond. Vernier Caliper is a measuring instrument used to determine the dimensions of an object with high precision. Unlike a simple ruler, it can measure internal and external dimensions as well as depths. The caliper consists of a main scale and a sliding vernier scale, which together allow users to read measurements down to fractions of a millimeter. This versatility makes it invaluable in fields like engineering, metalworking, and science. Let's take a closer look at its structure and how each part contributes to its accuracy. Vernier caliper is made up of several key components. The main scale runs along the body of the tool, providing the base measurement. Attached to this is the sliding vernier scale, which enhances accuracy. The jaws at the end are used for measuring external dimensions, while the smaller jaws are for internal measurements. There's also a depth rod that extends from the end for measuring depths. Each part is carefully designed to ensure precise readings, making the caliper a multifunctional instrument. Main scale of the Vernier caliper is similar to a ruler, marked with millimeters or inches. It provides the primary measurement, which is then refined by the Vernier scale. The main scale is fixed and does not move, serving as the reference point for all measurements. Its clear engraved markings ensure that readings are easy to see and interpret, which is crucial for accuracy. Understanding the main scale is the first step in mastering the Vernier caliper. Vernier scale is what sets this caliper apart from ordinary measuring tools. It slides along the main scale and allows users to read measurements with much greater precision, often to 0.02 or 0.001 inch. By aligning the lines on the Vernier scale with those on the main scale, you can determine the exact measurement. This ingenious design is what gives the Vernier caliper its reputation for accuracy in both professional and educational settings. Larger jaws at the end of the Vernier caliper are designed for measuring the external dimensions of objects, such as the diameter of a rod or the width of a block. These jaws are carefully machined to ensure they grip the object firmly without causing damage. When you close the jaws around an object, the measurement can be read directly from the scales. This feature is especially useful in manufacturing and quality control, where accuracy is paramount. Smaller jaws located at the top of the Vernier caliper are used for measuring the internal dimensions of objects, such as the diameter of a hole or the width of a slot. These jaws fit inside the object and expand outward, allowing for precise internal measurements. This capability is essential in fields like engineering, where knowing the exact size of holes or gaps can affect the fit and function of components. At the end of the Vernier caliper, you'll find a thin rod that extends as you move the sliding scale. This is the depth rod, and it's used to measure the depth of holes, slots, or recesses. Simply place the end of the caliper on the surface and extend the rod into the space you want to measure. The depth rod adds another layer of versatility to the tool, making it suitable for a wide range of measurement tasks. Proper handling of the Vernier caliper is crucial for accurate measurements. Hold the main body firmly in one hand, using your thumb to slide the Vernier scale smoothly. Avoid gripping too tightly, as this can cause the jaws to flex and affect the reading. Make sure the tool is clean and free from debris before use. With a steady hand and a gentle touch, you'll be able to achieve precise results every time. Before taking any measurements, it's important to check for zero error. Close the jaws completely and ensure the zero on the Vernier scale aligns with the zero on the main scale. If they don't, you'll need to account for this error in your readings. Regular calibration ensures that your caliper remains accurate over time. This step is especially important in professional settings where precision is critical. To read a measurement, first look at the main scale. Note the value just before the zero mark on the Vernier scale. This gives you the base measurement in millimeters or inches. The main scale reading is the foundation of your final result, so take care to read it accurately. Good lighting and a clean scale help ensure you don't miss any details. Next, examine the Vernier scale. Find the line on the Vernier scale that aligns exactly with a line on the main scale. The number of this line gives you the additional fraction to add to your main scale reading. This step allows you to measure with much greater precision than a standard ruler. Practice makes perfect, so take your time to get familiar with the process. Once you have both the main scale and Vernier scale readings, simply add them together to get the final measurement. For example, if the main scale reads 12 and the Vernier scale adds 0.04, your total measurement is 12.04. This method ensures that your results are as accurate as possible, making the Vernier caliper a powerful tool for detailed work. Measure the external dimension of an object, open the jaws and place them around the item. Gently close the jaws until they touch the object, making sure not to apply excessive force. Read the measurement as described earlier. This technique is commonly used for measuring rods, pipes, and blocks, ensuring that components fit together perfectly in assemblies. For internal measurements, use the smaller jaws at the top of the caliper. Insert them into the opening and expand gently until they touch the sides. Take care to keep the caliper straight for an accurate reading. This method is ideal for measuring the diameter of holes or the width of slots, which is essential in many engineering and manufacturing processes. To measure the depth of a hole or recess, extend the depth rod by sliding the scale. Place the end of the caliper on the surface and lower the rod into the space. Read the measurement as usual. This function is particularly useful in quality control, where knowing the exact depth of a feature can be critical to the performance of a part. Some Vernier calipers can also measure step heights. To do this, use the edge of the sliding jaw and the base of the main scale. Place the caliper on the lower step and extend the sliding jaw to the higher step. The difference in height can be read directly from the scale, providing another useful measurement option. Vernier calipers often feature both metric and imperial scales, making them versatile for different measurement systems. The metric scale is marked in millimeters while the imperial scale uses inches. Knowing how to switch between these systems is important, especially when working on international projects or with imported components. Modern vernier calipers are sometimes equipped with digital displays, making it even easier to read measurements. These digital calipers still use the same basic principles but eliminate the need to interpret the scales manually. They're especially helpful for beginners or for situations where speed and accuracy are both important. Vernier calipers offer several advantages over other measuring tools. They provide high precision, versatility, and the ability to measure different types of dimensions. Their robust construction ensures durability, and their relatively simple design makes them easy to use. These benefits make vernier calipers a go-to tool for professionals and students alike. While vernier calipers are highly accurate, they do have some limitations. They require careful handling and regular calibration to maintain accuracy. Reading the scales can be challenging for beginners, and the tool is not suitable for measuring very large objects. Understanding these limitations helps you choose the right tool for each job. Vernier calipers are used in a wide range of fields, from engineering and manufacturing to science and education. They're essential for tasks like quality control, machining, and laboratory experiments. Their ability to measure with high precision makes them invaluable wherever accuracy is required. In engineering, vernier calipers are used to ensure that parts meet exact specifications. They help verify the dimensions of components, check tolerances, and confirm that assemblies fit together correctly. This attention to detail is crucial for building reliable machines and structures. In scientific laboratories, vernier calipers are used to measure samples, apparatus, and experimental setups. Their precision ensures that experiments are conducted with accurate data, which is essential for reliable results. Students and researchers alike rely on calipers for a variety of measurement tasks. Manufacturing industries use vernier calipers to check the dimensions of products during and after production. This ensures that every item meets quality standards and fits with other components. The caliper's precision helps prevent costly errors and maintains consistency across batches. Vernier calipers are a common teaching tool in schools and universities. They help students learn about measurement, precision, and the importance of accuracy in science and engineering. Hands-on experience with calipers builds confidence and prepares students for real-world applications. To get the most accurate results with a vernier caliper, always ensure the tool is clean and free from dust or oil. Hold the caliper steady and avoid parallax errors by looking straight at the scale. Regularly check for zero error and calibrate as needed. With these tips, you'll consistently achieve precise measurements. Proper care extends the life of your vernier caliper. Store it in a protective case when not in use and avoid dropping or exposing it to moisture. Clean the tool with a soft cloth and apply a light oil to moving parts if necessary. Regular maintenance ensures smooth operation and reliable accuracy. If you encounter problems with your vernier caliper, check for dirt or debris that may affect movement. Make sure the jaws close completely and the scales are aligned. If readings are inconsistent, recalibrate the tool. Addressing these common issues quickly helps maintain measurement accuracy. While both vernier calipers and micrometers are used for precision measurement, they serve different purposes. Micrometers are typically used for even finer measurements, but they can only measure external dimensions. Vernier calipers, on the other hand, offer more versatility by measuring internal, external, and depth dimensions. In selecting a vernier caliper, consider the range, resolution, and material. Stainless steel calipers are durable and resistant to corrosion. Choose a tool with a measurement range that suits your needs and ensure the resolution is fine enough for your applications. A well-chosen caliper will serve you well for years. Analog vernier calipers require you to read the scales manually, while digital calipers display the measurement electronically. Analog models are reliable and don't require batteries, but digital calipers are faster and easier to use. The choice depends on your preference and the demands of your work. Always handle the vernier caliper with care. Avoid using excessive force, especially when measuring delicate objects. Keep your fingers clear of the jaws to prevent pinching. Store the tool safely when not in use to avoid damage or injury. Following these precautions ensures safe and effective use. Vernier caliper was invented by Pierre Vernier in the 17th century. His innovative scale allowed for much finer measurements than previous tools. Over the centuries, the design has evolved, but the basic principle remains the same. Today, vernier calipers are a testament to the enduring value of precision engineering. Modern vernier calipers have benefited from advances in materials and manufacturing. Stainless steel construction, digital displays, and improved ergonomics have made them more durable and user-friendly. These innovations ensure that the tool remains relevant in today's fast-paced technological world. In choosing and using vernier calipers, consider their environmental impact. Opt for durable tools that last longer and require fewer replacements. Proper maintenance reduces waste, and digital models with rechargeable batteries can help minimize environmental footprint. Responsible use benefits both you and the planet. Vernier calipers are available at a range of price points. Basic models are affordable and suitable for students, while professional-grade calipers with advanced features cost more. Consider your needs and budget when making a purchase. Investing in quality often pays off in the long run. Several brands are known for producing high-quality vernier calipers, including Mitutoyo, Starrett, and Fowler. These companies have built reputations for precision and reliability. Choosing a reputable brand can give you confidence in your measurements and ensure long-lasting performance. Some vernier calipers come with accessories like protective cases, calibration blocks, and spare batteries for digital models. These add-ons can enhance the usability and longevity of your tool. Consider what extras might be useful for your specific applications when making a purchase. Proper storage is key to maintaining your vernier caliper. Always return it to its case after use and keep it in a dry, dust-free environment. Avoid storing the tool in areas with extreme temperatures or humidity, as these can affect accuracy. Good storage habits protect your investment. When transporting your vernier caliper, use a padded case to prevent damage. Secure the tool so it doesn't move around during transit. If you're carrying it to a job site or classroom, make sure it's protected from bumps and drops. Careful transport ensures your caliper stays in top condition. Over time, some parts of your vernier caliper may wear out or become damaged. Many manufacturers offer replacement parts such as jaws or depth rods. Replacing worn components can extend the life of your tool and maintain its accuracy, saving you money in the long run. When your vernier caliper reaches the end of its life, consider recycling it. Many parts are made of metal and can be recycled. Digital models may contain batteries that require special disposal. Responsible disposal helps reduce environmental impact and supports sustainability. Vernier caliper is a versatile and precise measuring tool used in many fields. By understanding its parts, how to read it, and how to care for it, you can achieve accurate results in your work. Whether you're a student, engineer, or hobbyist, mastering the vernier caliper is a valuable skill that will serve you well in countless applications. Thank you for joining this comprehensive guide to vernier calipers. With practice and attention to detail, you'll be able to measure with confidence and precision. Remember to care for your tool, calibrate regularly, and always strive for accuracy. The skills you've learned today will help you tackle a wide range of measurement tasks both now and in the future.